For this third screencast over ecology, let's begin with biogeochemical cycles. Biogeochemical cycles trace the flow of elements through ecosystems. What they all share in common is that the materials cycle repeatedly through the ecosystem. This figure summarizes the flow of water through the ecosystem. Water vapor in the atmosphere condenses and falls as rain or snow. That water may soak into the soil and end up in aquifers, or may flow over land surfaces into streams, rivers, lakes, and perhaps ultimately into the ocean. Evaporation from these bodies of water ultimately returns to the atmosphere. A problem we have here in Oklahoma is overuse and pollution of groundwater that we use for drinking. Let's start the carbon cycle with carbon dioxide in the atmosphere. This carbon dioxide is used by plants during photosynthesis and is incorporated into organic molecules that are passed on to other organisms. Many of these organisms release carbon dioxide back into the atmosphere as they do cellular respiration. Carbon dioxide levels are increasing in the atmosphere due to our increasing use of fossil fuels. This graph shows the change in atmospheric carbon dioxide over the last several decades. Carbon dioxide levels are obviously increasing. The small up and down oscillations are due to changes in the rate of photosynthesis during the year. Carbon dioxide levels have changed dramatically in the past. For example, carbon dioxide levels have oscillated greatly during the ice ages. The lowest levels were during the coldest periods. Carbon dioxide levels have changed dramatically in the past. What is troubling is the rapid increase and the fact that levels are higher than they have been in the past several 100,000 years. Carbon dioxide is one of several different greenhouse gases. Greenhouse gases are important in moderating the temperature here on Earth. Because of increasing carbon dioxide and methane levels, the average temperature on Earth is increasing. Greenhouse gases trap heat by being more transparent to the incoming sun's rays than they are to the longer wavelength infrared radiation coming from the Earth's surface. This is similar to leaving your car parked in a sunny location with the windows rolled up. Sunlight comes in through the glass, warming the internal surfaces, and the heat doesn't escape as rapidly. This graph shows the change in average global temperature. The second half of the century shows a trend of increasing temperature. Notice the scale. The change has only been about 1 degree Fahrenheit, but this represents an average temperature increase of 1 degree every single day. That change is significant. The polar ice caps are melting. Ocean levels are increasing. Glaciers are receding. What we cannot say with certainty is that these trends will continue, but that does seem likely. There's a tremendous amount of nitrogen in the atmosphere in the form of nitrogen gas. In this form, the nitrogen is completely unavailable to plants. In a process called nitrogen fixation, nitrogen-fixing bacteria make nitrogen available. Humans also add large amounts of nitrogen to the ecosystems in the form of fertilizer. A problem we have here in northwest Oklahoma is nitrate pollution in our drinking water. The nitrates come from over-fertilization on agricultural and also urban lands, and human and animal waste. Sandy soils, which allow the nitrates to pass through quickly, increase this problem. An example of an environmental concern which we have created but have started to remedy is the ozone levels in the upper atmosphere. Ozone in the upper atmosphere is important because it strongly absorbs ultraviolet light. Chlorofluorocarbons destroy ozone. They cause the problem. Worldwide, we have greatly reduced CFC use and its release into the atmosphere. This has resulted in slowly increasing ozone levels in the upper atmosphere. Another set of problems we have had mixed results in correcting stems from organisms accumulating toxic substances in their bodies. Persistent pesticides like DDT, also heavy metals such as mercury and lead, and other pollutants like PCBs accumulate in the bodies of organisms. Low concentrations at the lower trophic levels accumulate, reaching toxic levels in the upper predators. This same process occurs in our bodies as well. Ecosystems worldwide are experiencing the loss of tremendous numbers of species, dozens of species every day. Directly or indirectly, most of these extinctions are the result of habitat loss. We are either taking ecosystems directly for our use, or our actions are altering habitats, making them unsuitable for the native species. One reason we've had such an impact on ecosystems is our demand for energy. It's like a 1-2 punch. We impact the environment by exploring for and extracting the energy sources, and then through the release of contaminants as the energy is released. The majority of our energy today comes from non-renewable sources, mostly oil, coal, natural gas. Renewable sources currently make up only about 12% of our energy use. These energy sources may reduce the impact that we have on the environment, but they still impact the world. Hydroelectric dams flood habitat and block migrating aquatic organisms. Wind turbines kill flying organisms and frighten away some species. Large-scale solar facilities use habitat. These are just a few of the impacts. There are many ways to make our society more sustainable and to have a lower impact on the environment. Reducing urban sprawl, organic farming, reducing meat consumption, using less energy and resources can all help. Let's take a break here.